Good afternoon, sir. I'm Julius Cabalquito from B. Ismari Charlie. Today I will discuss about our different topics: the steam turbine, boiler operation, main equipment, and the last is the thermo oil system. First, I will discuss about steam turbine. Steam turbine is a machine that obtains mechanical work on the stored energy of the steam. It has two main types: the impulse turbine and the reaction turbine. It has also advantages like little to no vibration, low maintenance costs, low weight, and minimal space requirements. Next is differentiate between the impulse turbine and the reaction turbine. An impulse turbine is made up of a row of nozzles followed by a ring of blades. The steam flows in the nozzle and strikes on the moving blades with kinetic energy only. The pressure remains constant during its flow through the moving blades. It is suitable for low discharge and has symmetrical blades. It required less maintenance work. An example of it is the Pilton wheel. While the reaction turbine is made up of a ring of fixed blades attached to the casing and row of similar blades mounted on the rotor. So the steam flows first through the guide mechanism and then flows through the moving blades, which possesses both pressure and kinetic energy. So the pressure of the steam reduces during its flow and blades are not symmetrical. It required more maintenance work and suitable for medium and high discharge. Example of it are the Francis turbine and the Kaplan turbine. Next is what is compounding. So we all know that compounding is the splitting up into two or more stages of the steam pressure or velocity change through a turbine. Next is differentiate between pressure compounding and velocity compounding. So the pressure compounding is the use of number of blades and nozzle to reduce the stem pressure progressively. This results in lower or acceptable stem speed flows and better turbine efficiency, while the velocity compounding is the use of single nozzle with an arrangement of several moving blades on a single disc. This results in poorer turbine efficiency, which would be acceptable in an Astern turbine. Next is I will discuss about the operating procedures about warming through a turbine, maneuvering, emergency Astern operation, full away, and port of arrival. First, I will discuss about warming through a steam turbine. First, open all the turbine casing and main stem like drain valves, and then ensure that all stem control valves at maneuvering station and around the turbine blades are closed. Then, all stem line drain valves should be open and start lubricating the oil pump. Check if the gravity tank is overflowing. Then, obtain clearance from the bridge to turn the shaft. Engage turning gear and rotate the turbines in each direction. Start the main circulating pump for the main condenser, then start condensate extraction pump with air ejector recirculation valve wide open. Next, open maneuvering valve bypass or warming through valve if fitted. So this allows a small amount of stem to pass unheated. This should be continuously turned until the temperature reaches 75 degrees Celsius at the LP turbine inlet after 1 hour. So this allows freedom of movement should be checked. Then the gland ceiling should now be partially opened up and the vacuum is increased. So the turning gear can now be disengaged. Then, through the main valve, short blasts of steam are now admitted to the turbine to spin the propeller in one revolution. This should be repeated 3 to 5 minutes for a period of 15 to 30 minutes. So the vacuum now can be raised to operational value and also the gland stem pressure. The turbine are now ready to use. So while waiting for the first movement from the bridge, and between the movements, the turbine must be turned ahead once every 5 minutes by the use of the stem blast. If there's any delay, the gland stem and vacuum should be reduced. Next is the operating procedures about the maneuvering. Once warmed through, the turbine rotor must not remain stationary more than few minutes because the rotor could sag or distort, which led to failure if not regularly rotated. So the astern operation involves admitting stem to the astern turbine, where any considerable period of astern running occurs. Turbine temperatures, noise levels, bearing, etc. must be closely observed. So the turbine manufacturer also may set time limit of about 30 minutes on continuous running astern. Next is the emergency astern operation. So when traveling at full speed ahead, any order of emergency stop is required. Then the safe operating procedure must be ignored or not required anymore. So a head astern is shut off by the use of an emergency trip. An astern valve is partly open to gradually increase of stem. So the turbine can thus be brought quickly to a stop condition and can be operated astern if required. Then astern operation will occur about 10 to 15 minutes before a similar state will occur the ship. So the use of emergency procedures can lead to serious damage in turbine, gearbox, or boilers, etc. Next operating procedures is in the full away. So the maneuvering revolutions are usually about 80% of the full away or the full speed condition. So the turbine can gradually brought up to full power operation once the full away command is received. So a process of that is taking 1 to 2 hours. So it's been very long. This also involves bringing into the use of turbo alternator which use stem to remove or blade at some stage from main turbines. Then check should be made on expansion arrangement, and also drains should be checked to be closed. So the condensate recirculation valve should be closed and astern stem valves tightly closed also. Lastly is the operating procedures about port arrival. So we all know prior to arriving at a port, the bridge should provide notice 1 to 2 hours to be able to enable the turbine to be brought down to maneuvering revolutions. So a diesel generate alternator will have to be started. Then the turbo alternator should be shut down and all the full away procedures must be done in reverse order. The next topic to discuss is about the operating principle on how to fire a boiler. First, you must check all the parameters in the boiler before operating it, like the water level in the water level gauge, fuel level in the fuel day tank, switches in the control panel, and the voltage in the main boiler board. You can also conduct a lamp control test to be able to know if the lamps are lighting or in good condition. So after that, we are going now to supply fed water in the boiler. So first, turn on the switches in the main boiler board. Then switch on the main switch and fed pump in the control panel. Open also the air vents and feed water valves so that the water can flow from the fed water tank to the water drum of the boiler. Then press the start button if the necessary valves are open and ready to supply fed water. Then wait until the water reaches 40% to 50%, which we can see in the water level gauge. If it reaches service water level, press the stop button and turn off the fed pump button. After that, we are now going to supply fuel to the burner in the boiler. First, we open fuel supply valve and air dampers before starting. So if all are ready and okay, push the start button in the control panel. Then wait for at least 30 seconds at least undergo pre-purging process. Then if the control panel indicated the flame on, you can now check the quality of the flame and adjust the supply of air if flame is too smoky. You can also conduct an intermittent firing in the boiler to avoid cracking of the boiler tubes from uneven expansion. Then observe and check the air vent for steam discharge and close the air vent if there's steam coming out or steam discharge. Then open the main steam valve gradually when it reaches the steam working pressure of the consumer. The topic to be discussed is about the main equipment, so I choose 4 main components: the superheater, combustion air fan, superheater, and the deaerator. First, I will talk about the superheater. So the superheater is used to lower temperature and superheated steam or other vapors. It also used to maintain constant pressure and permits operation of downstream process of equipment that designed for lower temperature. Next is the combustion air fan. So the purpose of this is to provide constant and precise airflow and provide enough air to the burner. It has also an air dampers attached to it to maintain the vacuum inside of it. Next is the superheater. So the use of superheater is to reheat the steam generated by the boiler and increasing its thermal energy. It also decreases the likelihood that will condense in the engine. It also produces superheated steam by converting wet or saturated steam into dry or superheated steam generated by the boiler. Lastly is the deaerator. So we all know that the deaerator is used to remove oxygen and other dissolved gases from the boiler fed water. So removing the dissolved oxygen will create a clean and deaerated water. So it also reduces corrosion and extend the life of steam generating boiler. The last topic to be discussed is about the thermo-oil system. I will name all the components, its function, and why it's important related to the topic. First is the oil-fired heater. So the oil-fired heater is a heating device which burns heating oils, diesel fuels, or other similar fuels. It is important because it is one who will heat the oil and it avoid thermal shock. Next is the expansion tank. So the expansion tank provides space for expansion of the heat transfer fluid with a change in temperature. Also to allow some place for the heat transfer fluid to expand. It's important because it handles expansion of water and prevent the water excessive pressure, damage to the pipes, valves, and heater itself. The next component is the economizer. So economizer preheated feed water by using flow of gases to improve The overall efficiency and heat transfer will take place without converting it into steam. So it is important because it helps save fuel costs, prolong the life of the boiler, and helps avoid thermal shock in the system. Next is filling pump, used to transfer and fill liquids from one location to another. It's important because it's the one who supply and transfer liquid from the storage and other places in the system. Next is the drain tank. So the drain tank is used in storing and draining byproducts created in separation phase like cracking liquid and other residual liquids. It's important because it is served as a storage of excess liquid. Next is the storage tank. Provide storage volume and pressure to the distribution system. It is important because it acts as a place we store the liquids and other gases. Next is the dump cooler. So, dump cooler where the excess energy from the exhaust gases of main engine will be dumped and stored in it. It's important because it avoids insufficient heat production in the system. Next is the circulation pump. So the circulation pump circulates fluids like oils from one place to another. It's important because it removes any residual heat in the heater. Next component is the degasser. So degasser is a device used to remove gases from fluid which could otherwise form bubbles. It's important because it reduces corrosion and extend the life of the boiler and other equipment. Next is I will discuss about the working operation, the starting and stopping of the system. First is the starting procedure. First, you start your system pump to get the fluid flowing through the system. Second, after you know you have a good flow, you apply the heat. Then the heat should be applied in 20 °F to 25 °F increments until the heat transfer fluids gets to a viscosity of 10 centipoise or less. So the reason for this is to ensure that you have a turbulent flow through the heater, where the heat transfer fluid can remove just as much heat as the heater can supply to the coil in the heater. And also there will be no thermal cracking of the oil. Third procedure is these increment steps are done by taking a system from 70 or 21 °C and increasing the heat by 20 °F and letting the system run until the temperature on the heater reaches 90 °F or 32 °C. So once the heater reads that, then dial it up another 20 °F or 11 °C. For once you heat transfer fluid is 10 centipoise or less, you can dial the heater to your operating temperature. Next is the shutting down procedure. The first step is turn off the heater first. Then let the pump continue to circulate the heat transfer fluid to remove any residual heat that is in the heater, the process and the pipes. The reason for this is to make sure that when the pump gets turned off, the residual heat in the various components of the system does not thermally crack the heat transfer fluid because it can affect it. 3 is once the temperature has dropped to 200 °F or 93 °C, the residual heat has been removed and you are now safe to shut off the pump. That's all. Thank you.